Okay, number 5. Oil, crude oil, fuel oil, and lubricating oil. And this is a big one. Lots of stuff to go through. Part 5. So the first question is February 2020. Question 5. List 5 products directly obtained from the distillation of crude oil, stating a typical use for each one on board the vessel. And then that's 5 marks. Part B, which is with reference to ISO 8217, aluminium and silicon oxides in fuels, state each of the following: how they get there, what effect they have on the engine's performance, and how they're removed from the fuel. With reference to ISO 8217, aluminium and silicon oxides in fuel, state how they get there, what effect they have on the engine performance, and how they're removed. That's also worth 5 marks in total, 2, 2, and 1. Distillation products, this is part A, is list 5 products directly obtained from distillation of crude oil, stating a typical use for each one on board the vessel. So if 5 products, I don't know, that would be probably like light, medium, and heavy types of fuel, or crude oil. So you probably get fuel oil from it, so like petrol, diesel, other things like kerosene. And then you probably get some lubrication oils from it as well, I would have thought. Larger hydrocarbons, and then, I don't know, bitumen, but you can't use bitumen on board a vessel, can you? Unless you're tarring a roof or something and tarring the vessel. Nah. Okay, let's see what we can get. So distillation products from crude oil and their use aboard the vessel. We've got 1, 2, 3, 4, 5. We've got fuel oil, bunker fuel, marine diesel oil, marine gas oil, lubricating oils, and asphalt. Yep, asphalt is bitumen, right? So that's just the usual stuff you get from crude oil. Okay, so fuel oil, number 1, is bunker fuel, the primary fuel used for powering the main propulsion system and generators on most commercial vessels. Bunker fuels come in various grades with different sulfur contents. All right, yes, okay, basic fuel oil, bunker fuel. Marine diesel oil, a lighter distillate fuel used for auxiliary engines, lighter engines, smaller engines, generators, and deck machinery on board ships. Marine diesel oil has a lower sulfur content compared to bunker fuel and offers better combustion characteristics. Burns better, it's lighter. Marine gas oil, a very low sulfur content diesel oil used in emission controlled engines or in areas with strict emission regulations. So the other ones do not have strict emission regulations. I guess it's only when you're near cities and near towns that you need strict emission regulations. The marine gas oil is similar to marine diesel oil, but with even lower sulfur levels. Lubricating oils. A variety of lubricating oils are derived from crude oil and used for various purposes on board. These include engine oil for internal combustion engines. Gear oil for gearboxes and transmissions, and hydraulic oils for hydraulic systems. All right. Asphalt. While not directly used on board, in its final form, asphalt, also known as bitumen, is a product of crude oil distillation. It can be used for waterproofing applications on some vessels or shore-based maintenance products there, like building roads, or you tar a roof with it, which is what I was saying. Or you probably has impermeable properties, but a bit ridiculous for modern day applications. Aluminium and silicon oxides in fuel according to ISO 8217. So this is part B, aluminium oxides. Part B was with reference to ISO 8217, aluminium and silicon oxides in fuel, state each of the following: how they get there, what effects they have, and how they're removed. So silicon and aluminium in the fuel, huh? Silicon will probably smooth things out, make it run a bit smoother. But aluminium, I don't know. We'll have to see. I don't know what it will do to engine performance. How they get there. Aluminium and silicon oxides can enter the marine fuels in various ways. Natural contamination, refinery processes, or storage and handling. Yeah, okay. Natural contamination. Trace amounts of these elements can be present naturally in the crude oil itself due to the geological formations. Yeah, it's just in the fuel to start with. Refinery processes. During the refining process, some clay-based material used for catalysts and absorbents might contribute towards aluminium and silicon oxides in the final fuel product. Yeah, that might be right, actually. Yeah, because you got aluminium and silicon in filters, basically, in catalysts, and absorbents to cleaning it. Storage and handling. Contamination may occur during storage and transportation due to contact with tanks, pipelines, or equipment containing these materials. Yeah, so if you store it in aluminium tanks, I'm sure it's going to get a bit of aluminium in it. All right. The effect on engine's performance. So that's how it gets in there. It gets in there because it was in there to start with. It was in there in the refining process or in the storage process. Okay. Effects on engine performance. The presence of aluminium and silicon oxides in fuel can have severe negative consequences. Oh, that's a shame. Can have several negative consequences for engine performance. Okay, it can have abrasive wear. It can cause it to be more abrasive. The fuel can be more abrasive. Deposit formation. It can have buildup like calcium does in your kidneys, right? It can have, it deposits over time, blocking up your arteries. Same thing here, it can block up your pump system probably. Increased maintenance needs. Okay, that's the same thing. Abrasive wear. These hard oxide particles can act as abrasives, increasing wear and tear on engine components like pistons, cylinder liners, and injector nozzles. Yeah, I was thinking about this the other day. The injectors that they're just spraying out the fuel, that of course because of the abrasive nature of the fuel, it's going to cause the holes in the injector to get bigger over time. So you would have to swap out the injector nozzles over time. Deposit formation. Aluminium and silicon oxides can contribute to a deposit buildup on pistons, injector tips, and exhaust valves. These deposits can hinder proper fuel injection, reduce combustion efficiency, and lead to power losses. Yeah, just like plaque, or your arteries as well. Increased maintenance needs. The abrasive wear and deposit formation caused by these contaminants means you have to do more frequent engine maintenance and replace their components. Increased maintenance needs. Yeah, well, this is because of deposits and abrasive wear, basically. So that was question B, is what effect do I have on engine performance? Or what effect? We haven't talked about the effect yet. That's just... what effect they'll have is they'll increase maintenance. Oh, I guess the deposit formation will cause higher friction, lower power losses, lower fuel delivery because it blocks up some of the the delivery system. Abrasive wear will do the opposite. It would cause too much to be delivered, or in the wrong kind of way. It affects the fuel nozzles. How are they removed from the fuel? There are several ways to remove or reduce the aluminium and silicon oxides in marine fuels. You can use centrifugal forces, so you can spin it. Microfiltration, so you can filter it. Fuel additives, I guess. Oh, so you clean a pool, like you clean a swimming pool, you put an additive and it clumps it together, so it'll filter it. It's easy to filter out. Careful storage and handling. You don't have to put it in there in the first place if you store it in the right kind of tanks. You can avoid putting it in certain tanks. Right, centrifugation is high-speed centrifuges can separate out solid oil contaminants. These including some oxide particles from the fuel oil. Microfiltration. Fine filters can trap smaller oxide particles that might not be removed by centrifuges. Fuel additives. Specific fuel additives can be used to disperse or agglomerate these oxides, preventing them from causing wear and tear or deposit formation. Careful storage and handling, and implementing proper storage and handling practices to minimize contamination from tanks or equipment can help prevent the introduction of these oxides in the first place. Yeah, the specific method of chosen removing aluminium and silicon oxides will depend on the severity of the contamination, economic factors, like how much you got to spend or how much equipment you can use, the fuel treatment capabilities available on board the vessel, we have available, following the guidelines set forth in ISO 8217, which specifies the maximum allowable limits for the various contaminants in marine fuels, helps to ensure fuel quality and protects engines from wear and tear. This is moving on to October 2023, which is to do with microbial infestation of distillate fuel. So with reference to microbial infestation of distillate fuel, Part A, B, C, and D. 1 mark, 2 marks, 5 marks, and 2 marks. Part A is describe what is meant by the term microbe. I guess it's a microorganism, isn't it? Something like that. Part B, that's only 1 mark. Part B is state what microbes need to survive. Basic biology. Oh, nice. Like air, food, stuff like that. Part C is describe the possible diesel engine problems with reference to microbial infestation of distillate fuel. And part D is describe how it can be identified for 2 marks. So the 5 marker is part C, which is describe the possible engine problems, which is a big one. So let's talk about microbial infestation of distillate fuel. What is a microbe? A microbe is a microscopic organism encompassing a diverse range of life forms, too small to be seen with the naked eye. These include bacteria, fungi, and algae. All right, so bacteria is a single-celled organism with a cell wall, some of which can cause biodegradation of fuels. So they eat the fuel, right? Okay, fungi, multicellular organisms that can grow as mold or yeast, also capable of degrading organic materials like fuel. They also eat the fuel. Algae, simple aquatic photosynthetic organisms that might be present in trace amounts in contaminated fuel storage. Yeah, I don't know about that. Maybe just in the water part of it, but apparently, yeah, a little bit of algae in there as well. I don't think we have to go into so much detail. It's just a one marker, right? So just a quick definition will be fine for describe what is meant by the term microbe. A microbe is a microscopic organism, too small to be seen with the naked eye. That would be fine. Yeah, and technically we're talking about bacteria and fungi, maybe algae a little bit. What do microbes need to survive? This is question B, 2 marks. Microbes involved in fuel degradation have specific requirements for survival and growth. Well, everything does. Every living thing will basically be the same thing. Moisture, nutrients, and favorable temperature. So they might or might not use, they might be anaerobic or aerobic, right? So they might use oxygen or not using oxygen. It doesn't say that. So microbes involved in fuel degradation have specific requirements for survival and growth. They need moisture, nutrients, and favorable temperature. Moisture. Water is essential for microbial activity. The presence of even small amounts of water in the fuel water interface in storage tanks can create a suitable environment for microbial growth. So if you have moisture in your fuel, you're more likely to get infestation. You could only get it. And if you have dry fuel, like there's no water in there, then you will not get an infestation. But I think there's always a little bit of water in fuel. Very difficult to get it without. I'm not sure. Nutrients. Microbes require nutrients for growth and reproduction. Distillate fuels themselves don't provide sufficient nutrients, but contaminants like dirt and debris and organic material introduced during storage or handling can act as nutrient sources. So they can't actually eat the fuel themselves, apparently. They have to live off the dirt and debris and organic material in there. So yeah, if you've got like old fuel sitting around, I know it can get infected, it can get moisture because of condensation, and then some dust and some particles can get blown in, I suppose, or just fallen in there. All right. Favorable temperature. Microbial growth rates are influenced by temperature. Warmer storage tank temperatures can accelerate microbial growth compared to cooler conditions. So temperature is another, what they need to survive. Well, they don't need temperature to survive, but they favor it. But what do they need to survive? They need moisture and nutrients. So they need water to be present, and there needs to be contaminants in there as well, which is the nutrients. That would be the contaminants, like organic material, dirt and debris. 2 marks, so I gave it 2 points. The favorable temperature is not necessary. It's just favorable. Unless you get really cold, and then even then they can probably survive frozen, right? But we're not going to go down to those kind of temperatures on a regular working day. Describe the possible diesel engine problems. 5 marks. All right, so there should be 5 points on this. We've got 4. So I guess we'll get the 5 marks for those 4, but we could probably think of a few more. Possible diesel engine problems caused by microbial infestation. Microbial growth in diesel fuel can lead to several problems in the engine. These are blocked filters, corrosion, degraded fuel quality, gel formation. So blocked filters. Microbial colonies are associated with biomass and can clog fuel filters, restricting fuel flow to the engine and potentially causing power losses or engine stalling. That's like gumming up the engine, isn't it? Blocked filters, or blocking up the filters, I suppose. Yeah, it's going to block up the filters. It's going to block up everything, isn't it? Including the injections, the fuel injectors and stuff like that. All right, corrosion. Certain microbes can produce byproducts like organic acids that contribute to fuel system corrosion, damaging pumps, injectors, and other components. So yep, as they're eating the fuel, or as they're eating the biomasses, they can produce acids which destroy the engine from the inside. Degraded fuel quality. Of course, microbial activity can break down the fuel components, so it does eat the fuel, reducing its energy content and hindering combustion efficiency. This can lead to increased fuel consumption and decreased engine power output. Yes, if your fuel is lower quality. Gel formation. In cold weather conditions, some microbes can produce gel-like substances that can thicken the fuel, further impeding the fuel flow and potentially causing engine startup issues. Those are possible diesel engine problems caused by the infestation. There's probably a couple more we could add on to that list. All right, but part D is identifying. Describe how it can be identified for 2 marks. So identifying microbial infestation. Several methods can be used to identify the presence of microbial contamination in diesel fuel. Number 1 is a visual inspection. Number 2 is spot tests. Number 3, analysis, fuel analysis. Visual inspection then. Fuel samples with a cloudy appearance, presence of water droplets, or visible sludge formation can indicate potential microbial growth. So if you look in the tank and it looks horrible, then you probably have a microbial infestation. Spot tests. Simple test kits can be used to check for the presence of microbial colonies in fuel samples, so you can do a proper chemical analysis on the thing. Well, that's a spot test. It's a simple on-site kit. And then fuel analysis, sending the fuel samples to a lab for a detailed analysis can identify specific types of microbes present and assess the severity of contamination. So proper lab analysis as well. But spot test kits, and then obviously just looking at it, a visual inspection. Regular fuel sampling and testing, along with proper storage practices to minimize water ingress and contamination, are crucial for preventing microbial growth and ensuring clean fuel for optimal engine performance. Okay, Jan 2023, with reference to, this is very similar, with reference to diesel engine fuel. So these are all very similar questions actually, but there's like slightly reworded. So explain the meaning of the term microbial contamination. So that's not describe what a microbe is, let's describe what is the meaning of microbial contamination, also just 1 mark. Describe the possible problems that the engine may encounter if the fuel received is contaminated with microbes. Very similar question to before, just slightly reworded. Explain how it can be avoided. Explain how microbial contamination can be avoided, and explain the actions taken if microbial contamination is severe. So slightly different aspects of the same topic. Okay, diesel engine fuel and microbial contamination. Microbial contamination in diesel fuels refers to the presence and growth of microorganisms like bacteria, fungi, and algae within the fuel. These microscopic organisms can thrive in certain conditions and can pose problems for the engine and the fuel system. That is the meaning of the term microbial contamination, is that you have microscopic organisms living in the fuel, growing in the fuel. 1 mark. Okay, next one is 4 marks. Describe the possible problems. The possible problems, we already know these, we just did them on the last one, but the possible problems are going to be blocked filters, corrosion, degraded fuel quality, and gel formation. So microbial contamination in diesel fuels can lead to several issues for the engine. Blocked filters, microbial colonies and associated biomass can clog fuel filters, restricting the fuel flow to the engine and potentially causing power losses or engine stalling. Get it all blocked, all gummed up. Corrosion. Certain microbes can produce byproducts like organic acids that contribute to fuel system corrosion, damaging pumps, injectors, and other components. Degraded fuel quality. Oh, so you can totally ruin the engine. I mean, if you've got infested fuel, because you can totally destroy all your injectors, your whole everything, basically. Degraded fuel quality. Microbial activity can break down fuel components, reducing its energy content and hindering combustion efficiency. This can lead to increased fuel consumption and decreased engine power output. Yeah, so you can still run the fuel if it's not like acidic, like if it hasn't got any of these organic acids in there, then you can still run it. It's going to be gummy. It's just going to destroy your engine. Depends on your situation, I suppose, if you're in a tight spot. Gel formation. In cold weather conditions, some microbes can produce gel-like substances that can thicken up the fuel, further impeding fuel flow and potentially causing engine startup issues. So same as before, basically. Part C is how to avoid it. How do we avoid microbial contamination? Well, we saw in the last one, it was caused by dirt, organic compounds being in the fuel, literally getting blown in there, and also water. So it may be due to condensation, stuff like that. Here are the key strategies to prevent microbial contamination in diesel fuel. Minimize water ingress. Water provides a medium for microbial growth. Maintain a watertight storage system and regularly drain any accumulated water from the fuel tank. Yeah, so if you've got an old beat up car, you don't want the fuel cap to be loose because when it rains, the water will get in. But obviously, when we talk about marine applications, there's a lot of water kicking around. So minimize water ingress. Water provides the medium for bacterial microbial growth. If we didn't have that water in there, it couldn't grow in the first place. Maintain watertight storage system. Regularly drain any accumulated water from the fuel tank. Proper storage practices. Store fuel in clean, sealed containers and avoid prolonged storage times, especially in warm, humid conditions. I think it's about 6 months, isn't it? Like good fuel you can store for about 6 months. Not sure. I'm sure it'll come up later on. And it says you should store it in proper sealed containers and not in warm, humid conditions if it can be avoided. Fuel filtration. Utilize appropriate fuel filters that can help trap microbial contaminants before they reach the engine. So you can filter the fuel. Biocide additives. Consider using a biocide fuel additives to prevent as a preventative measure. So you can put in pesticide, is what you're saying, to kill off the living organisms. These additives can inhibit the growth of microbes within the fuel. Yeah, sure they can. Regular fuel testing. Periodically test fuel samples for signs of microbial contamination. All right, just test it regularly. That is it. That was for 3 marks. Explain how it can be avoided, which is basically keeping it all sealed up. And test it regularly. Part D is explain the actions to be taken if the microbial contamination is severe, for 2 marks. So actions for severe microbial contamination. If microbial contamination is identified as severe, here's what to do. Do not operate the engine. Further running the engine with the contaminated fuel can exacerbate problems. So you're going to get worse. Drain and dispose of the fuel. Okay, so the bullet points are: do not operate the engine, drain the contaminated fuel off, clean the fuel system, refill with clean fuel, and consider a system inspection. So check it all out afterwards. So it's pretty simple. Let's go through them. Do not operate the engine. Yes, further running the engine with contaminated fuel can exacerbate problems. Drain and dispose of the contaminated fuel. Safely drain the contaminated fuel from the tank and dispose of it properly according to environmental regulations. Clean the fuel system. The fuel tank lines and filters need thorough cleaning to remove the microbial growth and debris. This might involve using specialized cleaning solutions and procedures. Refill with clean fuel. Only refill the system with fresh, clean fuel after ensuring proper cleaning of the fuel system. So you take the whole thing apart, clean it all out, let it dry off, I suppose, then refill it. Consider system inspection. In severe cases, a professional inspection of fuel system components might be necessary to assess any potential damage caused by the contamination. All right, by following these preventative measures and taking prompt action when contamination is discovered, you can minimize the risk of engine problems and ensure optimal performance from your diesel engine. Okay, April 2023, and this also came up in May 2018. And with reference to distillate fuel oil, explain each of the following: why it often needs treatment before the engine, why it sometimes needs cooling after the engine. 6 marks and 4 marks. With reference to distillate fuel oil, explain the following: why it often needs treatment before the engine, 6 marks. Why it sometimes needs cooling after the engine, 4 marks. Distillate fuel oil, treatment and cooling. Why distillate fuel oil needs treatment before the engine. Despite being a cleaner burning fuel compared to residue fuels, distillate fuel oil often requires treatment before entering the engine for several reasons. We can improve its stability. So we've got several bullet points. We can improve the stability of it. Corrosion protection, water contamination, combustion optimization, and cold flow properties. Improve stability. Distillate fuels are prone to degradation over time, especially during storage. Treatment with specific additives can enhance stability and prevent issues like gum formation or sediment buildup within the fuel system. Okay, so when they say why it needs treatment before the engine, they mean like adding specific additives can enhance stability. So you can add an additive to the fuel And that would be a fuel treatment. It doesn't need to be a physical process. It can just be a chemical process. All right. Corrosion protection. Distillate fuels lack natural natural. They're not lubricants. Distillate fuels are not lubricants. Yeah, they're like solvents, aren't they? Of some residual fuels. Additives can provide a protective film on internal engine components to minimize wear and corrosion. Okay, distillate fuels. Additives can provide a protective film. So you can add extra lubrication into your fuel so that your engine will run smoother. Seems like lead again, doesn't it? Lead. Good old lead, smooth. But I'm sure there's modern day ones that are not so damaging to our IQs. Water contamination. Even minor water content in the fuel can cause problems like ice crystal formation in cold weather or promote microbial growth. Treatment with water dispersants or demulsifiers can help mitigate these issues. Yeah, I don't know. I would have thought it'd be a physical process. Don't you just heat it up beforehand? A little bit of water can cause ice crystal formation in cold weather. Oh my goodness, in your fuel. That's crazy. Or promote microbial growth. That's obviously the bigger issue. Why does it need treatment for the engine? It's to remove the water, to increase corrosion protection, to improve stability. Yeah. Combustion optimization. Certain additives can act as detergents or dispersants, keeping contaminants suspended in the fuel and preventing them from clogging injectors or hindering proper combustion. Combustion optimization. So you can disperse contaminants. This is similar to, I would have thought, like a swimming pool. You can clean up a pool by clogging or by collecting everything together, by clumping all the contaminants together, or by dispersing them. So it says it acts like detergents or dispersants. Cold flow properties. In cold climates, distillate fuels can thicken and impede flow. Additives like wax dispersants can improve the fuel's cold flow properties and ensure proper fuel delivery to the engine. Okay, so part A was why it often needs treatment before the engine. Improves stability, makes it burn better, improves efficiency, it reduces damage to the engine because of corrosion protection. We can check for water contamination, or we can deal with water contamination. Combustion optimization, we can, yes, that's the same as making it burn better, enhancing the efficiency. Cold water properties, cold flow properties. When it's cold, you might want to lighten it up a little bit so it flows better. That's weird, huh? Okay, part B is distillate fuel doesn't always need cooling after the engine. Why? So why it sometimes needs cooling after the engine. Why does it sometimes need cooling? Distillate fuel doesn't always need cooling after the engine. Distillate fuel itself doesn't necessarily require cooling after exiting the engine. However, the engine itself generates significant heat during the operation, and the fuel plays a role in the heat transfer. What are you talking about? What do you mean? How can it sometimes need cooling? Distillate fuel oil. Why does it sometimes need cooling after the engine? Before the engine? After the engine? Don't you just burn it all off and then there's no more? And why would it need to be cooled? I don't understand. Why distillate fuel doesn't always need cooling after the engine? Distillate fuel itself doesn't necessarily require cooling after exiting the engine. However, the engine itself generates significant heat during its operation. The fuel plays a role in heat transfer. Heat transfer medium. Distillate fuels act as a heat transfer medium within the engine. It absorbs heat from the hot engine components like pistons and cylinder walls. Distillate fuel, not lubrication, but okay. Engine cooling system. The engine's primary cooling system is responsible for dissipating this absorbed heat. This system typically uses a coolant, a water-based solution circulating through the engine block, and a radiator to transfer heat to the surrounding air. Fuel temperature. The temperature of the fuel exiting the engine will be higher than the incoming fuel due to heat absorption. However, in most cases, the engine's cooling system effectively manages the overall engine temperature, and the heated fuel doesn't require a dedicated cooling system before returning to the tank, if applicable. So returning to the tank. So this is what we saw during because this is about diesel engines, this is what we saw on the last section, is that due to the injectors, about the governors governing the engine, if there's too much fuel supply, basically it gets siphoned off and it goes through a bypass valve and it goes back into the tank, I suppose. So it gets instead of going into the engine and burning off all that fuel, it just goes back into the tank, it gets pushed back again, and it will pick up some of that heat. But because of the efficient cooling system of the engine, it doesn't really require cooling. It sometimes will, sometimes won't. It says here, well, it sometimes needs cooling after the engine. I guess that's because it absorbed too much heat and it needs to be cooled off before it goes back into the tank. But it might or might not. This answer is a bit backwards because it's saying it doesn't always require cooling, but it should focus on when it does need cooling. Oh, here are the exceptions for that. So in specific situations, the fuel itself might require additional cooling before returning to the tank. Great. High engine loads or ambient temperatures. Under extreme engine loads or very hot ambient conditions, the engine cooling system might struggle to keep up. In such cases, a fuel cooler might be utilized to further cool the fuel before returning it to the tank and prevent excessive heating that could degrade its properties. Yes, okay. So if you're under a very high load or you're in very hot conditions. Yeah, all right. Hot ambient conditions. Closed loop fuel systems. Some engine configurations might have closed loop fuel systems where the fuel continuously circulates within the engine, and a dedicated fuel cooler might be used to maintain optimum fuel temperature within the loop. So there's you might need to cool it so it's optimum rather than being too hot. Just optimum, I suppose. Yeah. In summary, while distillate fuels does pick up heat within the engine's primary cooling system is usually sufficient. Additional fuel cooling might be necessary only under specific circumstances or in specific engine designs. Okay, June 2021, question 3, which is with reference to distillate fuel oil, material safety data sheets. Describe with examples the information which would be included in each of the following. Okay, I know nothing about this, so this will be interesting. With reference to distillate fuel oil material safety data sheets, describe with examples the information that would be included for each of the following. A is the hazards, that's 4 marks. B, first aid, 3 marks. C, firefighting measures, 3 marks. Hazards, first aid, and firefighting measures. Yeah, okay, so this is just standard procedure to deal with emergencies, health and safety, which is hazards, first aid, which is emergency situations, and firefighting, of course, as well. So health and safety, basically. Distillate fuel oil information, examples for specific sections. So distillate fuel oil material safety data sheets provide crucial information regarding the safe handling, storage, and disposal of this fuel. Let's check out some of the key details included in each section using examples. Part A was talking about the hazards. So explain the hazards. This section outlines potential hazards associated with distillate fuel oil exposure. So if you get it on you, right? If you get it in your eyes, on your skin. Examples of information you'll find is health hazards, inhalation. Exposure to fuel vapors can cause irritation of the respiratory system. Man, you guys, you engineers, I got a nice desk job here. You guys are working in the belly of the beast. Health hazards, inhalation. Exposure to fuel vapors can cause irritation to the respiratory system, coughing, dizziness, and headaches. Example would be inhalation of vapors may cause irritation of the nose, throat, and lungs. Symptoms may include coughing, shortness of breath, and nausea. Okay, so inhalation is a health hazard. Skin contact. Prolonged or repeated skin contact can cause dryness, irritation, or dermatitis. Example is prolonged or repeated contact with skin may cause irritation or drying. Yeah, that's basically the same thing, isn't it? Ingestion. Accidentally eating the fuel. Accidentally drinking. Ingestion. Swallowing fuel oil can be very harmful and lead to aspiration pneumonia. Example, harmful if swallowed, do not induce vomiting. What? Ingestion can lead to aspiration pneumonia. Well, I gotta look that up. Don't know what that is. Pneumonia is lungs. Aspiration is breathing. So swallowing can cause you to, because you might want to puke it up and get it back into your lungs again. That might be worse. So harmful if swallowed, do not induce vomiting, not because it's so bad for your digestive tract, but because it's very bad for your lungs, because it's volatile fuel. So like volatile means it evaporates quickly, which means it'll be easier to suck it into your lungs as you're puking it back out again, especially if it gets heated up to temperature, body temperature. Oh, okay. So fire hazards. I don't know about that. I have to look that up a bit more in detail. Like fire hazards. Fire hazards. So we just did health hazards. So this is still in the hazards section, part A. Fire hazards. Distillate fuel is a combustible liquid with a flash point. That's the minimum temperature to which it ignites, typically above 38 degrees C. So 38 degrees C is basically the temperature of the human body. So if you accidentally drink it, then you could catch fire if you, like, I don't know, puked it up or something. So typically above 38. It says above 38. Example, combustible liquid flash point, PMCC, greater than 38 degrees C or 100 degrees Fahrenheit. It's exactly the human body temperature. Well, like, you know, a bit higher, like half a degree higher than human body temperature. That's so strange. That is obviously fire hazards and flashpoint is, of course, it can catch fire. It can just spontaneously combust almost. Environmental hazards as well is the last one. So that we're still talking about the hazards, part A, and there's 4 marks. And we have to, this is with reference to the safety data sheets, described with examples. So the last one is environmental hazards. Spills or leaks can contaminate soil and water, posing risks to aquatic life in the ecosystem. For example, it's harmful to aquatic organisms and may cause long-term adverse effects in the aquatic environment. Oh, the examples are specific language taken from the data sheets. So these are like warnings that you get on the container. So combustible liquid flashpoint is 38 degrees, is the fire hazard. Harmful to aquatic organisms, may cause long-term adverse effects to aquatic environment, would be written on the side of the container. And inhalation might cause like problems with your nose and throat, lungs, etc. Okay, so those are the hazards: the health hazards, fire hazards, and environmental hazards. Again, what we're always looking for are these 3 things. Really, is human health and safety, damaging the equipment, which is in this case a fire hazard, and then damage to the environment, which is environmental damage. Part B is first aid. So with reference to distillate fuel oil, talk about first aid. So let's see what we have for first aid. This section provides immediate response steps in case of accident exposure to distillate fuel. Examples include inhalation, skin contact, eye contact, and ingestion. So we're going to look at these 4 different cases: inhalation, skin contact, eye contact, and ingestion. So what should you do in case of inhalation is move the person to fresh air and provide medical attention if breathing becomes difficult. An example is, if inhaled, remove victim to fresh air to keep at rest position, keep at rest in a position comfortable for breathing. Call a poison control center or doctor or physician if you feel unwell. So move them to fresh air environment and put them in a position that makes it easy to breathe, basically to stop them from suffocating. Skin contact. Immediate remove contaminated clothing and wash the affected area thoroughly with soap and water. For example, remove contaminated clothing and wash skin thoroughly with soap and water, or use Recognize's skin cleanser. So if you get it on your skin, you should take off the contaminated clothing and clean it with soap and water. And probably go see the medic afterwards, right? It depends on how severe it is, because obviously you can get on your hands and arms occasionally as you're working with it. Eye contact. Flush eyes with clean water for at least 15 minutes, holding eyelids open. Seek medical attention immediately. An example of this would be immediately flush eyes with plenty of water for at least 15 minutes. Remove contact lenses, if present and easy to do. Continue rinsing. Get medical attention immediately. Yeah, so eye contact is very severe. Is very severe. Skin contact is less so. Inhalation as well is very, very serious. Ingestion. Do not induce vomiting. Seek immediate medical attention. Example, do not induce vomiting. Call a poison control center or doctor or physician immediately. Yeah, I suppose we should give an example. It's giving an example from the actual data sheets. It's saying here, with reference to the distillate oil, fuel oil material safety data sheets, describe with examples of the information that would be included for each of the following. The information that would be included. So I don't know if it's examples of real life situations or examples from the data sheet. It looks like they're giving examples from the data sheet that you would see. All right. So that was part B, which was first aid. Part C is the firefighting measures. Okay, so what should we do in case of fire? This section details proper procedure for extinguishing fires involved in distillate fuel oil and associated safety considerations. Okay, suitable extinguishing media. So you have to have a fire extinguisher. Usable extinguishing, unsuitable extinguishing media. Okay, this section, firefighting measures. So what would you find in that data sheet is to explain what is suitable, what is not suitable for putting the fire out, specific hazards arising from the chemical, from the actual chemical being burnt, rather than the extinguishing media, and protective equipment that you should be using while putting the fire out. So suitable extinguishing media, water spray or dry chemical powder or carbon dioxide can be used to extinguish fires involving distillate fuel oil. Water spray or dry chemical powder or CO2. Example, use water spray, dry chemical powder or carbon dioxide to extinguish, in quotation marks. So that's taken from the datasheet. Unsuitable extinguishing media. A direct water stream might not be effective and could spread the burning fuel. Do not use solid water stream. An example is, do not use a solid water stream as it may spread the fire. Yeah, I think you could give real life examples of these. So you wouldn't want to pour a whole bunch of water onto a large amount of fuel if it's burning, because you just wash it away and it would spread the fire to another place. For example, specific hazards arising from the chemical. Burning fuel oil can produce dense smoke and toxic fumes containing carbon monoxide and other harmful gases. An example of this is, in a fire may emit acrid smoke and irritating fumes. Okay, protective equipment for firefighters. I'm just thinking about the last one, specific hazards. So of course, yes, some chemicals will come with a warning that will say they will, if they catch fire, they'll be, or the distillate fuels, I should say, they'll produce acrid smoke. Protective equipment for firefighters. Firefighters should wear self-contained breathing apparatus, SCBA, not quite scuba, but almost scuba. I think it is the same as scuba, isn't it? And full protective clothing while responding to a fuel oil fire. Example is, firefighters should wear self-contained breathing apparatus and full protective clothing. Remember that these are just examples. There's information in the MSDS. That is the MSDS is the material safety data sheets, and the material data safety sheets. So all about data, data about the materials, right? About the materials you're working with. So you're working with distillate fuels as well as loads of other stuff. So it gives you specifics about them, right? Will vary depending on the exact fuel oil product and manufacturer. Always refer to the most recent version of the MSDS for a specific fuel oil that you're using. So look it up so you know what you're working with. Okay, October 2023. Sketch a distillate fuel oil centrifugal purifier showing the direction of all fluid flows, labeling the main components. That's 10 marks. Sketch a distillate fuel oil centrifugal purifier showing the direction of all fluid flows, labeling the main components. Distillate fuel oil centrifugal purifier. Oh my goodness. So it spins to separate out the different layers of the fuel, to get out the water and contaminants, stuff like that. Okay, let's have a look then. See how big this thing is. Quite big, but we'll go through it. So distillate fuel oil centrifugal purifier. A distillate fuel oil centrifugal purifier is a device that utilizes centrifugal force to separate contaminants like water and solids from the fuel oil. Here's a breakdown of the main components and the fluid flow directions. The components are: 1 is the inlet housing, 2 the feed pump, which is optional. Number 3, distributor. Number 4, centrifuge bowl or centrifugal bowl. Number 5 is the disc stack, which is optional. 6, heavy phase solids and water collection chamber. The heavy phase collection chamber, that's the solids and water. Light phase collection chamber, which is the clean fuel, where the clean fuel oil goes. Heavy phase outlet, light phase outlet to drain off the fuel, to drain off the contaminants. Drive system is a motor that actually drives it, and control system, which allows you to control it. So let's have a look at each one. The inlet housing. This is the point of entry for the dirty fuel oil. Feed pump. An additional pump located before the inlet housing can be used to ensure a consistent flow of fuel oil entering the purifier. Distributor. This component evenly distributes the incoming fuel oil into the centrifugal bowl. Centrifugal bowl. Centrifuge bowl is what it says. This is a cylindrical high-speed rotating vessel that separates the fuel oil from the contaminants based on the densities. Disk stack. Some purifiers utilize a stack of disks within the bowl to improve separation efficiency by creating a larger effective settling area. Okay. Heavy phase. So that's solids and water, collection chamber, the heavy phase collection chamber. The denser contaminants like water and solids accumulate at the periphery of the rotating bowl due to centrifugal force. So they get forced outwards because they are heavier, and the lighter ones would be in the center. Light phase collection chamber. This is for the clean fuel oil. Less dense clean fuel oil accumulates near the center of the bowl, rotating bowl. Wow, rotating, yeah. Heavy phase outlet. This allows the separated water and solids to exit the bowl. Light phase outlet. The cleaned fuel oil exit the bowl through this outlet. Drive system. A motor provides the power to rotate the centrifugal bowl at high speeds, typically several thousand revolutions per minute. Control system. Modern purifiers might have an electronic control system that monitors and regulates various parameters like speed, temperature, and differential pressure. Okay, so yeah, you can control it, get a bit more control, means you can make it cleaner, do what you want with it, but more electronics to fix when they break. Okay, fluid flow direction. Number 1, there's 8 points to this. Number 1, dirty fuel enters the inlet housing. Number 2, the fuel oil might pass through the optional feed pump to ensure a consistent flow. Number 3, the distributor directs the incoming fuel oil towards the center of the rotating centrifugal bowl. Number 4, as the bowl spins at high speed, centrifugal forces separate the fluids based on their densities. Number 5, denser contaminants, which are the water and solids, migrate outwards and accumulate at the periphery of the bowl in the heavy phase collection chamber. Number 6, less dense clean fuel oil accumulates near the center of the bowl in the light phase collection chamber. Number 7, separated water and solids are continuously discharged from the bowl through the heavy phase outlet. And number 8 is the cleaned fuel oil exits the bowl through the light phase outlet. That's pretty simple. You put it in, spins it round, pulls out the clean oil from the center, pushes out the contaminants on the outside. Okay, and that's what we had to do. We had to describe the direction or show the direction of the fluids flowing and label all the main components, and also sketch a distillate fuel oil centrifugal purifier. So now you know what the components are. We can put it all together and draw a picture of it. Note the specific design and configuration. The centrifugal purifier might vary depending on the manufacturer and application. Some purifiers might have a self-cleaning mechanism for the heavy phase chamber, eliminating the need for frequent manual cleaning. Modern purifiers can be automated and integrated into a larger fuel oil handling system. By utilizing centrifugal force, a distillate fuel oil centrifugal purifier effectively removes contaminants, ensuring cleaner fuel for optimal engine performance and reduced wear and tear. February 2022. With reference to distillate fuel, explain a potential problem for each of the following, stating how they can be avoided. We've got A, B, and C, 3 points. We've got flash point, which is 3 marks, wax, which is 3 marks, and microbes, which is 4 marks. With reference to distillate fuel, explain the potential problem for each of the following and how they can be avoided. How can we avoid flash points, wax, and microbes? Microbes would be microbial infestation. We just saw that as, not let water get in there and dirt. Flashpoint is, I suppose, keep it cool and maybe keep it sealed. So I don't know, keep it cool. And wax, I don't know what wax is. Let's have a look. Distillate fuel oil, potential problems and avoidance. Flashpoint. The problem is that distillate fuel have a flashpoint, a minimum temperature at which it can vaporize and ignite. If the fuel oil temperature reaches or exceeds a flashpoint in the presence of an ignition source, a fire can occur. This is a safety concern during storage, handling, and refueling. So how to avoid storage. Store fuel oil in designated cool and well-ventilated areas away from heat sources and ignition sources like open flames and sparks. Handling. Implement proper handling procedures to minimize risks of spills and ensure safe transfer during refueling. and the fuel selection. In some cases, depending on application and climate, you might consider using a distillate fuel with a higher flash point for increased safety margins. So that was just talking about flash point and explain it and how it may be avoided. I saw there was something else about on another one about like oily rags left lying around can reach flash points even if they're in a locked container. They can just get to a certain temperature and they just start burning. So they just burst into flames basically. Stuff like that. So they explain it. There's good storage, proper handling, and fuel selection. Actually, you can choose the correct oil. If you're going through a hot environment, you might want to use different fuels from a cold environment to avoid flash points. Okay, part B is wax. So describe the problem and then how to avoid it. What is the problem with wax? Distillate fuels contain paraffin waxes, which can solidify at low temperatures. This can cause problems like filter plugging and also poor flow. With the filter plugging, the wax crystals can clog fuel filters, restricting fuel flow to the engine and potentially leading to engine stalling or power losses. Poor flow. Wax formation can thicken the fuel, hindering proper fuel flow within the system. So this is the opposite, is that we got too cool a fuel and it actually starts to solidify, and the other one is flashpoint is too hot a fuel and it starts to burn as it catches fire. So how to avoid fuel selection when operating in cold weather conditions. So yes, exactly the same, but this time we're going to select the appropriate fuel for cold weather rather than for hot weather. Using distillate fuel with a lower cloud point, the temperature at which wax crystals begin to form is crucial. That's called a cloud point. Okay, they form cloudy fuel. Makes sense. That's wax crystals where you get solid bits of wax like forming inside the fuel. You see that with some oils in your kitchen, for example. I see it with coconut oil tends to do it, something like that. It tends to go between solid and liquid, or something along those lines. This ensures fuel remains liquid at the expected operating temperatures. Yes, okay. So if you're going to a cold environment, if you're doing an Arctic cruise, you might want to select a different type of fuel than if you're doing if you're going to a hot place like at the Caribbean or going through the Middle East. You'd have to have a different type of fuel for safety and starting conditions. To get the thing moving. Fuel additives. Specific cold flow improver additives can be added to lower the cloud point of the fuel and prevent wax crystals formation at moderate to cold temperatures. So you can add a bit of fuel additive to prevent wax forming. Proper storage. Avoid storing fuel oil for extended periods in extremely cold conditions, as this can promote wax separation or solidification. You can separate, it's been separated, but then I was wondering, can you just pull off not use the wax, just use the fuel if you can separate it out? A bit difficult, I suppose. Part C was describe what is the problem with microbes and how it may be avoided. So microbes, the problem with microbial growth, which is bacteria and fungi, can occur in distillate fuel oil, especially if there's water contamination. Microbes can cause several issues. Blocked filters, microbial colonies can clog fuel filters, restricting fuel flow. Corrosion, microbial activity can produce byproducts that contribute to fuel system corrosion. We've already seen this, they can produce organic acids. Degraded fuel quality, microbial activity can break down fuel components, reducing its energy content and hindering combustion efficiency. And how do you avoid this? Is you minimize water ingress, maintain a watertight storage system, and regularly drain any accumulated water from the fuel tank. Proper storage practices. Store fuel in clean, sealed containers and avoid prolonged storage times, especially in warm and humid conditions. Biocide additives. This is adding in like pesticide, well, not quite pesticide, but adding in stuff to kill off the microbes that live inside of it. Consider using biocide fuel additives as a preventative measure to inhibit microbial growth within the fuel. Regular fuel testing, periodically test fuel samples for signs of microbial contamination. Okay, October 2022, number 6. Describe with the aid of a sketch a coalescer type distillate fuel oil filter. A coalescer type distillate fuel oil filter. A distillate fuel oil coalescer filter. A coalescer type distillate fuel oil filter is a device that utilizes the principle of coalescence to remove water from the fuel oil. Here's a breakdown of its operation and its key components. The function, unlike traditional filter media, unlike a traditional filter that can simply trap water droplets, a coalescer filter promotes the merging of smaller water droplets dispersed throughout the fuel into larger water droplets. Oh, so it coalesces the water in the fuel, or it coalesces the contaminants into a bigger contaminant so you can remove it easier. These larger droplets can then be more easily separated from the fuel oil due to the difference in density. Water is denser than oil, so it sinks to the bottom. That's good. Okay, the components are, there's 5 components we've got here, and that's the filter housing, the inlet port, the coalescing media, and then the drainage mechanism, and then the outlet port. So the filter housing, this sturdy container holds all the internal components of the filter. They go around the outside. Inlet port, the dirty fuel oil containing water droplets enters the filter through this port. Coalescing media, this is the heart of the filter and is typically made out of a pleated or layered synthetic material with a high surface area. The specific design of the media can vary, but it is designed to do 2 things: to capture water droplets and also coalescence. To capture water droplets, as the fuel oil passes through the media, the water droplets come into contact with the fibers and adhere to them due to surface tension. Coalescence. The media promotes the merging of these smaller water droplets into larger ones due to the phenomenon of coalescence. Water droplets naturally tend to minimize the surface area and merge into larger droplets. Merging into larger droplets achieves this. Oh, so it's like almost like a catalyst. It's probably made from a hydrophilic material, so like it's designed to make water stick to it basically, and then all the water sticks to the rest of the water and they collect together in big chunks into big little droplets, like large droplets. But it's basically like a filter. It is a filter. It's not like anything crazy special. Drainage mechanism, a mechanism that such as a drain valve or an automated float system, allows the accumulated larger water droplets to be periodically drained from the filter housing. So it gets drained off, of course. The cleaned fuel oil, now with significantly reduced water content, exits the filter through this port. The benefits of coalescer filters, right? So we're talking about describe it, really describe it. So we're just talking about it. So the benefits of them are high water removal efficiency. Coalescer filters can remove very small water droplets from fuel oil, offering superior performance compared with traditional filters. Reduced maintenance. By efficiently separating water, coalescer filters can extend the lifespan of downstream filters and reduce maintenance frequency, so it can help other filters. Improved engine performance. Water in the fuel oil leads to problems like corrosion, reduced combustion efficiency, and potential engine damage. Coalescer filters help prevent these by ensuring these issues by ensuring cleaner, drier fuel for the engine. Okay, the question doesn't actually ask for this. The question asks for a diagram, right? Describe with the aid of a sketch, or describe with the aid of a sketch what it does. Okay, so it does ask for a description of it. So this is a very detailed description of it. And of course, we can draw a picture, but we do have to explain the process, or be beneficial to explain the process. So these are the components and the process and the benefits of it. So all this information is actually relevant, and we just need to add a picture in here, really. Okay, applications. Coalescer filters are widely used in applications where clean, dry fuel is essential, such as on-board marine engines and generators, industrial diesel engines and generators, construction equipment, and off-road vehicles operating in wet and humid environments. So a lot for marine applications. By utilizing coalescing technology, these filters effectively remove water from distillate fuel oil, ensuring optimum engine performance and protection from water-related problems. Okay, October 2022. Describe with the aid of a sketch a typical distillate fuel supply system for a diesel engine, including all safety devices. Describe with the aid of a sketch a typical distillate fuel supply system for a diesel engine, including all safety devices. Okay, distillate fuel supply system for diesel engine, including safety devices. A typical distillate fuel supply system for a diesel engine ensures a clean, steady flow of fuel to the engine while incorporating safety features to prevent fires, spills, and hazards. Here's a breakdown of the key components and safety devices. Okay, so it's a system to get the fuel to the engine, and if there's a leak or something, it will stop the fuel so it doesn't spray all over the place and cause a disastrous fire, I suppose. Components are, it's made using a fuel tank, or it includes a fuel tank, a fuel day tank, which might be optional, fuel lines, fuel filter primary, fuel transfer pump, which is optional, but a fuel transfer pump, a fuel shutoff valve, a secondary fuel filter, a fuel injection pump, and a fuel injection system. So 9 parts. Some of them are optional, some of them are extra. So a fuel tank. Let's start at the beginning with a fuel tank. The components are, this sturdy container holds the main reserve of the diesel fuel. It's often made of metal to ensure strength, and is ventilated to allow air intake as the fuel is consumed. The safety devices are a filler cap. A secured cap with a seal prevents fuel spills during transport and storage. Yeah, so it's got a cap on it, right? To stop you from just tipping it all out all over the place like a regular car has a filler cap. The vent line, and if you tip it on its side, is what I'm trying to say. It doesn't spill all over the place. So vent line, this allows for air into the tank as the fuel is used, preventing a vacuum that could hinder fuel flow. It may incorporate a flame arrestor to prevent external ignition sources from reaching the fuel tank interior, right? So it will stop you from sucking a flame into the vent as you pull in the extra air, because obviously you're draining the fuel out of the tank, and that has to be replaced with air, so it sucks in the air from the outside. And it might include a system to stop, a flame arrestor to stop it sucking in any source of ignition, any fire, basically. Number 2 is a fuel day tank. This is optional. Some systems utilize a small day tank mounted closer to the engine. This tank serves as a buffer and provides a more consistent fuel supply to the engine. I suppose if you're going to be swapping over tanks during a long voyage, you might want to do that. You might have a small one to keep the engine running. Number 3 is fuel lines. Durable hoses and pipes carry fuel from the tank to the engine. The safety devices are the material and the clamps and connections. The material is fuel lines are made from materials resistant to fuel degradation and are able to withstand operating pressures, so high pressure and not corroded by the fuel. Clamps and connections. Secure clamps ensure tight connections at all points to prevent leaks. Yeah, Jubilee clips, right? Something along those lines, but proper ones, not bits of wire. Sticky tape. No. Number 4 is a fuel filter, primary fuel filter. This filter removes large particles like dirt, rust, and debris from the fuel before it enters the engine. Pretty standard. That's the primary fuel filter. Number 5 is fuel transfer pump, and this is optional. Some systems, especially those with a high fuel consumption or located higher than the engine, might utilize a pump to ensure a consistent flow of fuel to the engine. Higher than the engine. You mean that the engine's high up and the fuel tank is lower than the engine. So you need to pump up fuel transfer pump. Yeah, you might need an extra pump to ensure that it has a continuous supply of fuel if your engine is in a strange position, I suppose. Or you're not running on level ground all the time. So fuel shutoff valve. This manually operated valve allows for stopping the fuel flow to the engine for maintenance or emergency shutdowns. It's a safety device. This valve serves as a critical safety measure to isolate the fuel system in case of emergencies. Okay, part 7 is secondary fuel filter, and this is optional. Some systems might have an additional finer filter located closer to the engine to remove any remaining microscopic contaminants. Number 8 is fuel injection pump. This pump pressurizes the fuel and delivers it to the engine's injectors at high pressure. And number 9 is the fuel injection system. This system meters and injects the pressurized fuel directly into the engine cylinders at the appropriate time during the combustion cycle. So that was described with the aid of a sketch, a typical distillate fuel supply system for a diesel engine, including all safety devices. So we've got safety devices on there, which are things like the filler cap, the vent line on the fuel tank, On the fuel lines, we've got the material, and the clamps and the connections are made for suitable material. The fuel shut-off valve is a safety device. Okay, and the rest of it just describes how it works. Additional safety considerations: the fuel line routing. Fuel lines should be routed away from heat sources and protected from physical damage. Yep, spill contaminant. A spill tray or pan can be placed under the fuel filter to prevent or other potential leak points to contain any spills. Regular maintenance, regular inspection, and replacement of fuel filters and other components are crucial to ensure proper system function and prevent issues. By incorporating these components and safety devices, a distillate fuel supply system ensures a clean and reliable fuel source for the diesel engine, while minimizing risk of fires, leaks, and other hazards. Okay, next one is January 2019. Question 5. Describe how contamination of fuel oil by each of the following can occur. Microbials, or microbes, sorry, that's 2 marks, and sodium, 2 marks. Describe how to avoid fuel system and engine related problems with reference to the 2 contaminants in part A. So we've seen this stuff before, we haven't seen sodium yet, but microbes, obviously, usual stuff, bacteria and algae no, it's not, I'm missing one, bacteria and something else. Anyway, and then the other one is part 2 is describe how to avoid fuel system and engine related problems with reference to these 2 parts. Okay, describe how contamination of fuel by each of the following can occur. Microbes. So a source of contamination, microbes, getting water into the engine, of course. So water ingress, the primary culprit for microbial growth in the water is in the fuel oil is water contamination. Microbes require moisture to survive and reproduce. Even small amounts of water at the fuel oil interface in the storage tanks can create a suitable environment for microbial growth. Look at just a little bit of water, just like sitting on top of the oil or underneath the oil. Yeah, sit on top of the oil, I guess. Dirty storage tanks, improperly cleaned or maintained tanks can harbor microbial colonies that can then contaminate the fuel during filling and transfer. So if you've got dirty tanks, you don't get rid of it. You just keep them infected. Fuel transfer practices. Contamination can occur during fuel transfer if equipment or hoses are not cleaned, or in the transfer process, or if the transfer process allows for water or other microbial-laden substances to enter the fuel. Okay, so when you're filling up your car with petrol, you got to be careful you don't infect it, I guess. I guess on cars it's so small you don't really notice it. It doesn't get a chance. Or they put contaminants, or they put like pesticides, those microbial things, into the fuel. Okay, part 2, sodium. How do you get contamination of sodium? Well, sodium, because of the sodium chloride, which is salt. So seawater ingress. In marine applications, the biggest risk of sodium contamination comes from seawater intrusion. Leaks in the heat exchangers or breaches in the fuel system can allow seawater to mix with the fuel oil, introducing sodium chloride, which is salt. Contaminated fuel source. Less commonly, sodium contamination can occur if the fuel itself is sourced from a well or reserve with naturally high sodium content. So you could already have it in there to start with. Improper additive use. Using certain additives containing sodium-based compounds for purposes like corrosion inhibition can introduce sodium into the fuel if not used within recommended guidelines. Part B is describe how to avoid the fuel system and engine related problems with reference to the 2 contaminations. So, okay, so part B is describe how to avoid fuel system and engine related problems with reference to the 2 contaminants in part A, so that's the microbes and sodium. How to avoid fuel and system and fuel system and engine related problems to do with the sodium and the microbes. Avoiding system and engine problems. Microbes is minimize water ingress, maintain a watertight storage system, and regularly drain any accumulated water from the fuel tank. We've heard all this before. Proper storage practices. Store fuel in clean, sealed containers and avoid prolonged storage times, especially in warm and humid conditions. Biocide Additives. Consider using biocide fuel additives as a preventive measure to inhibit microbial growth within the fuel. Regular fuel testing. Periodically test fuel samples for signs of microbial contamination. Fuel filtration. Regularly replace fuel filters to remove any captured microbes or debris. So change your filters. All right. Sodium. Regular system inspections. For marine applications, conduct regular inspections of heat exchangers and fuel system for leaks or potential seawater intrusion points. Fuel source monitoring. If operating in regions with known high sodium fuel sources, consider alternative fuel options or implement additional purification steps. So if you know you're going to be buying high sodium fuel, consider not buying it or work out a way to purify it. Proper use of additives. Follow the manufacturer's recommendations for dosage and application of any sodium-based fuel additives. Fuel analysis. For critical applications, consider routine fuel analysis to monitor sodium content and identify potential contamination risks. That was how to avoid the problems with the engine. Well, you avoid having sodium in the system is what they said. How you do that is by checking it, basically. Don't buy sodium contaminated fuel. That's how you avoid having problems with your engine, is you just don't have it in the first place. The micros and the source of contamination. Yeah, we looked at this before. So it's basically prevention is better than cure. Avoiding. Yep. Okay. By taking these preventive measures, you can significantly reduce the risk of both microbial and sodium contamination, preventing problems within the fuel system and engine. Clean fuel ensures optimal engine performance, efficiency, and lifespan. So basically, prevention is better than cure. January 2018, number 5. Explain what is meant by the following fuel terms. Cloud point, 2 marks. Compatibility, 2 marks. Describe how to avoid fuel system and engine-related problems with reference to these 2 terms in Part A, which are cloud point and compatibility, 6 marks. Distillate fuel oil terms and avoiding problems. So fuel terms, cloud point. This is where a cloud point is where you get crystallization of waxes in the fuel, right? So it's like the fuel starts to solidify, so it goes cloudy. That's why it's called that. The cloud point of a distillate fuel refers to the temperature at which the wax crystals begin to form and separate from the liquid fuel. As the temperature drops below the cloud point, the fuel becomes cloudy due to suspended wax crystals. Right, well, that was basically it. Yes, compatibility, no idea, haven't looked at this yet. Compatibility, definition. Fuel compatibility refers to the ability of 2 different fuels to be mixed without causing adverse effects. Incompatible fuels can lead to problems when blended, such as sediment formation. Incompatible fuels can react and form a sludge or sediment that can clog filters and fuel lines. Increased viscosity. Mixing incompatible fuels can cause a resulting blend to thicken, hindering proper fuel flow within the engine. Well, it doesn't quite make a sediment, I suppose, but it still turns into a thick sludge. Corrosion. Certain blends of fuel might lead to increased corrosion within the fuel system components. All right, so compatibility, you can mix 2 fuels together. And there might be a few problems like increased viscosity, sediment formation, or even corrosion. I'm sure there's a few more. I have to look those up as well. Avoiding problems then. How do you avoid problems with cloud point? Fuel selection, or can't you just heat it a little bit? It doesn't say that. It says fuel selection and fuel additives, but I'm sure we could warm it a little bit. When operating cold weather conditions, it's crucial to choose a distillate fuel with a cloud point lower than the expected minimum operating temperature. This ensures the fuel remains liquid and flows freely within the fuel system, preventing problems like filter clogging and engine stalling. Fuel additives. In some cases, cold flow improver additives can be used to lower the cloud point of the existing fuel and improve its performance in colder temperatures. I guess that's the same as just adding in, not the same, but along a similar idea of mixing salt with water, is it lowers the freezing point. So it lowers the freezing point of the fuel if you mix in an impurity in there. There'd have to be something that's volatile and can burn, but you can mix it in to the fuel and it would drop the freezing point, which is the cloud point, which is because it's going solid. Okay, compatibility. Fuel storage and handling. Always store different fuel types in separate tanks and avoid mixing them unless otherwise confirmed to be compatible. Clearly label storage tanks to prevent accidental mixing. Fuel supply guidance. Consult the fuel supplier to refer to technical data sheets for information on fuel compatibility. Fuel testing in critical applications or when mixing fuels is unavoidable, consider fuel compatibility testing before using the blend in the engine. This can help to identify potential issues and prevent problems within the fuel system and engine. So you take a bit of a sample, mix together, and then see if you're going to get those problems, which was like forming a sediment and increasing viscosity, or basically does it make a horrible corrosive mix. By understanding cloud point and fuel compatibility, you can select appropriate fuel type and avoid mixing incompatible fuels to help ensure smooth engine operation, prevents filter clogging, and minimizes wear and tear on the system components. So that was the question for describe how to avoid the problems with fuel system and engine related problems with reference to the two in the part A. So really we're describing the problems, which is things like, cloud point would cause blocking. So it does say this, where cloud point would cause filter problems and stuff like that. And how do we avoid that is make sure they're warm enough for the cloud point and make sure the fuels are actually compatible, I suppose, to avoid them forming a sludge and stuff like that. All right. Next one is May 2018. Explain what is meant by flashpoint of bunker fuel stored on board. Part A, 1 mark, flashpoint of bunker fuel stored on board. Describe the importance of knowing the flashpoint of bunker fuel stored on board. Describe a method in common use for ascertaining the flashpoint of bunker fuel. State the SOLAS, S-O-L-A-S, SOLAS requirements with respect to temperature for storage of bunker fuel in the engine room. Right, okay. The flashpoint of bunker fuel refers to the lowest temperature at which the fuel vapor can ignite in presence of an ignition source like a spark. It's a crucial parameter for understanding the fire risk associated with bunker fuel storage and handling on board ship. The importance of knowing the flashpoint, that was it. It's just like it's the lowest temperature at which it can then ignite, given it has a ignition. The part B is describe the importance of knowing the flashpoint. It's safety, isn't it? I mean, come on. Importance of, it's all things. It's the safety for the health and safety. It's always these three things. Health and safety for people on board the ship is to make sure the ship doesn't catch fire, so preserving the equipment, preventing damage, and then of course that will probably lead to environmental damage or reducing environmental damage, so things don't accidentally catch fire. And if you can put them out, still contamination, isn't it? So know the flashpoint of the bunker. So the importance of knowing the flashpoint. This is part B. It's 1 mark, right? So this is a bit of over-explanation, but okay. Knowing the flashpoint of bunker stored on board is critical for several reasons: safety, regulation compliance, and safe storage and handling. Safety, so those three things, yeah. Safety. Fuels with lower flashpoints are more susceptible to igniting and pose a greater fire risk or a fire hazard. Understanding the flashpoint allows for implementing appropriate safety measures during storage, handling, and refueling operations. Yep, that's basically the 1 point you need. Also, there's a couple more. Regulation and compliance. The International Maritime Organization, the IMO, regulations under the SOLAS, Safety of Life at Sea Convention, have minimum flashpoint requirements for bunker fuel storage on board ships. Knowing the flashpoint ensures compliance with these regulations, and that's for health and safety reasons. So basically it's the same thing. And abiding by the rules and the law is because of safety. Why do you need to know? It's because of safety. Safe storage and handling. Flashpoint information helps determine appropriate storage temperatures and handling procedures. For example, fuels with lower flashpoints might require stricter temperature control or specific ventilation measures. Yeah, you don't want to be storing all your fuel and it just bursts into flames all the time. You want to be able to store it well, right? So yeah, that's the importance of knowing it. Okay, part C is ascertaining bunker fuel flashpoint. Now this is 4 marks. Describe a method in common use for ascertaining it. Ascertaining bunker fuel flashpoint. A common method for determining the flashpoint of bunker fuel on board is the PMCC, Penske-Martins closed cup test. This standardized test uses a small sealed cup filled with a fuel sample. The cup is gradually heated and the small flame is introduced at regular intervals to check if the vapor ignites. The temperature at which the vapor first ignites is recorded as the flash point. A common method for determining the flash point of bunker fuel on board the ship is the Penske-Martin's closed cup test. Why is it closed cup? The standardized test uses a small sealed cup filled with a fuel sample. The cup is gradually heated and a flame is introduced at regular intervals to check if it ignites. The temperature at which the vapor first ignites is recorded as its flash point. I had to read it twice because it's so simple. You literally heat up a cup and see if it catches fire, and then when it does, that's its flash point. PMCC. No, I don't think I can find it. Cup. Okay, we'll look at it later. But ascertaining that's it basically. Okay, right. Just like you heat up a cup of fuel and then try to set fire to it. Apparently, cold fuel doesn't burn very well. It doesn't burn below its flash point. So you can't just, what is it like in the movies? You can't just flick a match into a load of petrol or something. It just kind of goes out. It has to be heated. Something like that, Don't know. Don't really set fire to things very often. With petrol. So state the SOLAS requirements. This is part D. State the SOLAS requirements with respect to the temperature for storage of bunker fuel in the engine room. What are the requirements of the SOLAS requirements for storage of bunker fuel in the engine room? SOLAS regulations do not directly specify a storage temperature for bunker fuel within the engine room. However, they do set a minimum flash point requirement for the fuel itself. Currently, the minimum flash point for all distillate and residual grades of bunker fuel, except from designated marine fuel, that's DMX fuel, stored or used on board ships must not be less than 60 degrees C. The minimum flash point for all fuels, for all distillate and residual grades of bunker fuel, must not be less than 60 degrees C. So it won't be able to catch fire unless it gets over 60 degrees C. That's what we're saying. So everywhere you go on planet Earth should not be that hot. Well, depends on if you're trapped inside like a tight, hot space like an engine room, and then it probably would get that hot. It is important to note that while flash point is a crucial safety parameter, it is not the only factor determining fire risk. Other factors like fuel volatility, oh my goodness. Other factors like fuel volatility and storage conditions also play a role. Maintaining safe storage practices and adhering to the SOLAS regulations are essential for safe handling on board ships. Yeah, these need to be expanded because they're worth 4 marks each, and it's only giving like a little thing. Describe a method. State the SOLAS requirement with respect to temperature for storage of bunker. So it's basically the SOLAS requirements with respect to temperature is that you mustn't have the temperature greater than 60 degrees because that's the minimum flash point, I suppose. Or that's what they're saying with respect to temperature. I don't know. We'll have to look at some more answers on these. Maybe the questions are a bit weirdly worded, or maybe the answers here are not so great. But it does give us something at least to work with. So the recommendation is that, although the regulations is that the flash point must not be less than 60 degrees Celsius. Okay, so next one is now getting into lubricating oils. But they might be very similar to our fuel oil. So let's have a look. The lubricating oil, then October 2020 and also April 2023. Part A, explain what is meant by microbial degradation of lubricating oil, 4 marks. State 4 indications that could be observed if lubricating oil was suffering from microbial degradation. Describe 2 actions that should be taken on detecting the early start of microbial degradation on the main engine lubricating oil. Okay, so explain what is meant by the degradation, 4 marks. State 4 indications that could be observed, 4 observations, 4 signs, 4 marks. Describe 2 actions that could be should be taken upon detecting early start of microbial degradation. So what should you do about it? Okay, microbial degradation of lubricating oil. Microbial degradation of lubricating oil refers to the process by which microorganisms like bacteria and fungi, that was it, fungi, I couldn't get that one earlier, bacteria and fungi break down the components of the oil. These microbes utilize the oil as a food source, and their activity can lead to several negative consequences for the oil's performance and lifespan. Indications of microbial degradation. Here are 4 indications that could be observed. Oh, that was just the first part. Sorry, they did it really quickly. That's the microbial degradation. What is it? It is the microbes using the oil as a food source, and it's caused by bacteria and fungi. Explain what is meant by it. Yeah, that'll do. For 4 marks. That's very quick, isn't it? All right. So let's have a deeper look into it. Indications of microbial degradation. This is part B, also 4 marks. 4 indications. Here are 4 indications that could be observed if the lubricating oil is suffering from microbial degradation. Increased acidity. Microbial activity often produces organic acids as byproducts. Yeah, it does, I suppose. I'm just trying to think of an example from my kitchen or something like that. Like yeast eats sugar to make alcohol, and alcohol does degrade into vinegar. So, well, it turns into an acid, right? So, yeah. Here are 4 indications that could be observed. So, increased acidity. Microbial activity often produces organic acids as byproducts. These can cause the oil's total base number, the TBN, to decrease. Base as in acidic. All right, base as in alkali, right? Total base number, base as in alkali, to decrease, indicating a decline in its ability to neutralize acids and prevent corrosion. Also, that's like the pH decreasing, I suppose. If the base decreases, it becomes less base, so it becomes more acidic. Just like pH, you go down the pH scale, more acidic. Right, number 2 is increased viscosity. Microbial growth can lead to formation of sludge and biomasses within the oil, increasing its viscosity and hindering its ability to flow freely within the engine. Abnormal odors. Some microbes can produce foul-smelling byproducts, leading to a notable change in the oil's odor. So these are 4 indications. So you should be able to see its acidity increasing. You can also test it for its viscosity or see its viscosity increasing. Also, if it smells bad or smells different. And number 4, its presence of sediment. Microbial colonies and debris can accumulate as sediment at the bottom of the sump or in the oil analysis samples. All right, part C, describe 2 actions that should be taken upon detecting this microbial degradation in the engine's lubricating oil. And this is only for 2 marks. Early detection. If you suspect early microbial degradation in your engine's lubricating oil, 2 crucial actions should be taken immediately. Number 1 is oil sampling and analysis. Collect a fresh oil sample and send it to the lab for analysis. This analysis can confirm the presence of microbes and identify specific types involved. It can be also measure the total base number, the TBN, and viscosity to assess the extent of the degradation. So you might have an infection and you can see how bad it is, basically. All right. Identify and address the root cause. Microbial growth typically requires moisture as a catalyst. Investigate potential sources of water ingress into the lubrication system, such as leaks in the cooling system or condensation buildup. Addressing the root cause is essential to prevent further microbial growth. Okay, so that's it. Early detection is moisture. Investigate potential sources. Early detection actions. That's not detection. If you suspect, 2 crucial actions should be taken immediately. Identify and address the root cause. So it's to stop the water getting into the system. So you think, I've got a microbial infestation. That's probably because there's moisture getting in somewhere. We should look for that. The second thing is to analyze the lubricating oil, to see how bad it is. So properly analyze it and also stop the water getting into the system. By taking these steps promptly, you can potentially mitigate the damage caused by microbial activity and extend the lifespan of your engine oil. Early detection and appropriate action can help prevent costly repairs and downtime. October 2021. Describe 2 methods of cylinder linear lubrication in medium-speed diesel engine. 6 marks. Part B is describe possible effects of each of the following. Insufficient lubrication and excessive lubrication. So we talk about lubricating oil. So describe 2 methods of cylinder lubrication in medium speed engines. That's 6 marks. Let's have a look. Cylinder liner lubrication. My bad. It is describe 2 methods of cylinder liner lubrication in medium speed engines. Cylinder liner lubrication in medium speed engines. There are two primary methods for lubricating cylinder liners in medium-speed diesel engines. Number one is forced lubrication. Number two is splash lubrication, or a dipping system. Right, that is it, basically. Forced lubrication and splash lubrication. So forced lubrication is this method utilizes an external pump and a dedicated lubrication system to deliver the measured amount of lubricating oil directly to the cylinder liner walls. The oil is typically injected through quills or nozzles positioned strategically on the cylinder liner. The mechanism is the pressurized oil forms a thin film between the piston rings and the cylinder liner, reducing friction and wear during piston movement. Excessive oil drains back to the engine sump through designated channels. The benefits are precise control over oil delivery, allowing for optimizing lubrication based on engine load and operating conditions. So you can control it. So heavy loads, you can give more oil. Lighter loads, you can give less because you're squirting the oil into it, I suppose. Ensure a consistent oil film for effective wear reduction. Yeah. Okay, that's the forced lubrication type, where you are pumping it in. Part two is, or the other version is, because it asks for two versions in the question, it says describe two methods. So here's the second method, is splash lubrication, or it's also called a dipping system. The description is, this is a simpler method where the crankcase oil bath serves as a primary source of lubrication. The rotating components, like connecting rods, churn the oil in the sump, splashing it onto the cylinder walls. Okay, so you just have a big old sump in it, the timing chain and everything just goes through this oil and splashes it all over the place. Mechanism. As the crankshaft rotates, the connecting rods dip into the oil bath and splash oil upwards, lubricating the cylinder liners and pistons. The excessive oil drains back into the sump through gravity. The benefits are it's a simple design with few moving parts, resulting in lower maintenance requirements, suitable for engines with less demanding lubrication requirements. Of course, the negative effects are you can't control it, right? It doesn't say anything about the negative effects. The forced lubrication, you have much more control of what's going on. Okay, part B is describe the possible effects of insufficient lubrication. So that would be caused by the splash lubrication method. You could potentially have insufficient lubrication, or excessive lubrication, which could also be caused by a splash, I would have thought, or by both of them really, and you have to adjust. One you can adjust, to the other one you can't do so much. So excessive lubrication and insufficient lubrication. So what are the effects of insufficient lubrication? Well, friction, heating up, stuff like, what do you expect it to be? Insufficient lubrication due to factors like low oil level, clogged oil passages, or incorrect oil viscosity can lead to several negative consequences. So if you've got low oil level, your filters or your passages, your pump systems are not operating properly, they're clogged, or you've put the wrong oil into the engine in the first place, will have insufficient lubrication, can cause insufficient lubrication. These would cause increased friction and wear. Without a proper oil film, metal-to-metal contact between the piston rings and the liner increases friction, leading to an increased and accelerated wear and potential scuffing or scoring of the cylinder liner surfaces. Increased heat generation. Friction creates heat. Insufficient lubrication can lead to excessive buildup within the cylinder. This can damage pistons, rings, and other engine components. Piston ring sticking. High temperatures can cause piston rings to stick in their grooves, reducing their sealing effectiveness and leading to compression losses and increased blow-by of combustion gases. Potential for seizures. In extreme cases of insufficient lubrication, complete seizure can occur, where the piston ring becomes welded to the cylinder liner due to excessive heat and friction, causing catastrophic engine failure. Oh no, the whole thing gets so hot, it just welds itself on there. So that was insufficient lubrication. Now we have a look at excessive lubrication. While insufficient lubrication is a major concern, excessive lubrication can also have detrimental effects. We can have increased oil consumption. Excessive oil being delivered to the cylinders can lead to a higher oil consumption as more oil is burned in the combustion process. Yeah, because it gets drawn inside of the cylinder, so it actually gets burnt out and then kicked out of the exhaust. as it goes inside of the cylinder as you lubricate on the outside, but as the piston moves down, it then becomes on the inside. Spark plug fouling. Excessive oil can reach the combustion chamber and foul the spark plugs, because it doesn't burn cleanly, hindering proper ignition and engine performance. Increased emissions. Burning excessive oil contributes to an increased emissions of hydrocarbons and pollutants. So it's all the same thing, really. The oil getting inside of the combustion cylinder, inside of the combustion process, is because there's too much of it. Basically, it can not quite leak in there, but it can be like pushed in there. Degraded power output. Oil film buildup on cylinder walls can increase friction and slightly reduce engine power output. Oil film buildup. Oh, right. So like an actual, it doesn't burn cleanly. So oil film buildup, is that the after it's been burnt? I guess it can increase friction and slightly reduce engine output. Yeah, I guess it makes a bit of a clag on the inside. It dirties up the pistons, right? Environmental impact. Excessive oil consumption leads to increased oil disposal needs, requiring proper handling and potentially creating environmental concerns. Maintaining proper lubrication through regular oil changes, using the correct oil viscosity, and monitoring oil levels is crucial for optimal engine performance, longevity, and reduced emissions. So same as usual, environmental impact. For the environmental impact, decreased efficiency, no health and safety on it though. While insufficient lubrication is may concern, this is extra, too much lubrication, basically because it leaks into the combustion process. June 2021, with reference to diesel engine lubricating oil, so that diesel engine lubricating oil, explain how oil may be contaminated during service. That's 5 marks. Describe how to keep the oil in a satisfactory condition. That's 5 marks. Explain how the oil may become contaminated during service. So, contamination during service. Diesel engine lubricating oil can be contaminated during service due to several factors. These factors are combustion byproducts, oxidation, wear debris, water ingress, and dirt and dust ingress. So combustion byproducts. Incomplete combustion within the engine allows unburnt fuel, soot particles, and acidic blow-by gases to enter the crankcase, contaminating the oil. Yeah, so it's mixing the gases that are inside the combustion chamber, and they can leak out past the piston rings into the crankcase, which is where your lubricating oil is, and they get mixed together, and that's not good. That will contaminate it due to combustion byproducts. Oxidation. Lubricating oil is exposed to oxygen at high operating temperatures, leading to gradual oil oxidation and thickening. This process can also generate acidic byproducts that degrade the oil's properties. So it's just running at a high temperature with oxygen present. Not much we can do about that, except for have it in a vacuum or something. Oh, that's ridiculous. Or have it in a non-oxygen environment, which is ridiculous as well. So nothing we can do about it, really. Wear debris. Normal engine wear generates small metal particles from components like piston rings and bearings. These particles can become suspended in the oil, acting as abrasives and accelerating wear. Yeah, like shavings and particles in the oil. Water ingress, coolant leaks, condensation buildup, or improper storage can allow moisture to enter the oil. Water contamination reduces the oil's lubricity, its lubricating abilities. Water contamination reduces the oil's lubricity and promotes corrosion within the engine. Dirt and dust ingress. Airborne dirt and dust particles can enter the engine through the air intake system or during oil changes if proper cleanliness is not maintained. These contaminants can increase wear and clog filters. Airborne and dust particles. So you can get dust particles in your lubrication system if it enters during the maintenance process. Okay, that was part A, which is explain how the oil may be contaminated during service. Part B is describe how to keep the oil in satisfactory condition. Keeping your oil in satisfactory condition. Maintaining your diesel engine's lubricating oil in good condition is crucial for optimum engine performance, longevity, and reduced maintenance costs. Here are some key strategies. We've got 5. Regular oil changes. So that's not really maintaining it's maintaining the engine's oil, I suppose, yeah. But you can just change it, get new stuff, and then it'll be in good condition. So regular oil changes, use the correct oil grade and type. Yes, okay. Air filter maintenance, keep it clean. Yes, coolant system maintenance, and oil analysis. So prevention is better than cure, as usual. So follow the manufacturer's, this is regular oil changes. Follow the manufacturer's recommended oil change intervals based on engine use and operating conditions. Frequent oil changes help remove contaminants and maintain the oil's lubricating properties. It might be that there's a few more for the marine applications of this, of course, because you might have a built-in filter. There's a couple more down here as well. So there's actually 7 in total. I got down to oil analysis, and then after that we got proper storage as well, and cleanliness during oil changes as well. So let's go back to the top. Regular oil changes. Follow the manufacturer's recommended oil change intervals based on engine use and operating conditions. Frequent oil changes help remove contaminants and maintain the oil's lubricating properties. Use the correct oil grade and type. Always use the oil grade and type specified by the engine manufacturer. The viscosity and additive package of the oil are formulated for your specific engine's needs. Okay, air filter maintenance. A properly functioning air filter prevents excessive dirt and dust ingress into the engine, reducing wear and contamination of the oil. Coolant system maintenance. Regularly inspect the coolant system for leaks to minimize the risk of coolant mixing with the oil. That'd be bad, wouldn't it? Getting the coolant all mixed in there. Oil analysis. Periodic oil analysis can identify early signs of contamination, wear, or degradation before they cause significant damage. This allows for preventative maintenance and potentially extended oil change intervals. So check the oil. Proper storage. Store engine oil in sealed containers in a cool, dry place to prevent oxidation and contamination. Cleanliness during oil changes. Maintain a clean work area and use clean tools during oil changes to minimize the risk of introducing dirt and debris into the engine. By following these practices, you can help ensure the engine oil remains in good condition, promoting extended engine life and optimal performance. Remember, clean oil is vital for a healthy diesel engine. Okay, that was for describe how to keep it in satisfactory condition. All those different points, yeah. Keep it changing it, keep the filters clean. When you change the oil, make sure you don't get any dirt in it, stuff like that. February 2021. Describe with reasons 5 properties required of lubricating oils. 10 marks. So there's like 5 and then a reason, so it's like another mark each. So describe it and then give a reason for it. Describe with reasons 5 properties required of lubricating oils. Lubricating oils play a critical role in minimizing friction and wear within an engine. Here are 5 essential properties required of lubricating oil, along with the reasons why they're important. Number 1, viscosity. Has to be just right. It can't be too thick or too thin. Film strength. So it makes a film and it covers the engine parts. Detergency and dispersive properties. Don't know what that is. Have to look at that. Detergency and dispersive properties. Oh, it can spread out any contaminants inside of it so they don't clump together. Oxidation stability. Yes, we talked about this just now. It doesn't oxidize under a high temperature, not regular oxygen environment. And anti-wear additives. Yes, okay. So adding something in there to help not wear the engine down, I suppose. So viscosity. Number 1. The reason is viscosity refers to a fluid's resistance to flow. Viscosity refers to a fluid's resistance to flow. Yeah, like how runny it is. That's what viscosity is, how runny it is. Engine oil needs to have the right viscosity to provide lubricating film between moving parts. If it's too thin, if the oil is too thin, it won't create a strong enough film to adequately separate moving parts, leading to an increased friction and wear. If the oil is too thin, it won't create a strong enough film to adequately separate moving parts. Okay, right. If it's too thick oil will have difficulty flowing freely at low temperatures. causing increased resistance during startup and potentially leading to oil starvation in certain engine components. Oh, especially when the engine is cold, yes. Film strength. Number 2, film strength. The reason is film strength refers to the oil's ability to maintain its lubricating film under pressure and high temperatures encountered within an engine. Okay, so it has to maintain like coverage even at high pressures and high temperatures without changing drastically. These are the 5 properties required for lubricating oils. Yeah. Okay. So film strength. A strong film oil prevents metal-to-metal contact between components, minimizing friction and wear even under demanding operating conditions. A weak film can rupture under pressure or high temperatures, leading to increased friction and potential engine damage. All right, number 3, detergency and dispersive properties. Engine operation generates contaminants like soot, dirt, and wear debris. These contaminants can increase wear and sludge formation if not properly managed. Detergent additives in the oil help suspend contaminants within the oil, preventing them from settling on engine components and forming a sludge. So it keeps them suspended. That's what a detergent does. Dispersive properties keep the suspended contaminants from clumping together and ensure they are carried throughout the oil until they are removed by filter during an oil change. So they keep the particles suspended. That's what dispersive means. Okay, they keep it suspended. Number 4 is oxidation stability. The engine oil is exposed to high temperature and oxygen, leading to a gradual oxidation. Oxidation can thicken the oil, increase its acidity, and reduce its ability to lubricate effectively. High oxidation stability. Oil with high oxidation stability resists thickening and breakdown due to oxidation, maintaining its lubricating properties for longer service intervals. So you want it to have a high oxidation stability. Anti-wear additives. Even with a lubricating film, some metal-to-metal contact can occur within the engine. Anti-wear additives form a microscopic protective layer of metal on metal surfaces, further reducing wear during operation. Effective anti-wear additives. These additives help minimize wear on critical engine components, extending engine lifespan, reducing maintenance costs. Could you give us an example? I don't have an example of anti-wear additives. But I would say silicon, but it's definitely not silicon, because like lead would be it, actually, wouldn't it? Yeah, that way. It's in the oil, not the fuel. It's in the lubricating oil. I don't know. I have to look it up. By possessing these 5 key properties, lubricating oil ensures smooth operation, minimizes friction and wear, protects the engine components, and extends engine life. Okay, let's do another one. January 2023. State Part A is state 4 functions of lubricating oil. That's 4 marks. Part B, I, and Part B, I, comes in 2 parts. Explain each of the following terms: hydrostatic lubrication and boundary lubrication. Part C is state 1 advantage and 1 disadvantage of using grease as a lubricant in a plain bearing. And those are 2 marks each for each of those. So lubricating oil. Functions and types of lubrication. Functions of lubricating oil. Part A is lubricating oil plays a critical role in engine operation by performing several essential functions. It reduces friction. It acts as heat transfer, so a conductor of heat, corrosion protection, and sealing and leak prevention. It reduces friction. The primary function of lubricating oil is to create a thin film between moving parts, reducing friction and minimizing wear on components. This ensures smooth operation and improves engine efficiency. Part 2 is heat transfer. The engine operation generates significant heat. Lubricating oil helps transfer that heat away from the critical components like pistons, rings, and bearings, preventing overheating and potential damage. Part 3 is corrosion protection. Lubricating oil forms a protective layer on metal surfaces, inhibiting corrosion caused by moisture, combustion byproducts, or acidic contaminants within the engine. Yeah, because combustion produces H2O. It might produce it very hot, and it might get pushed out as exhaust gases, but it still produces a bit of moisture in there as well. Sealing and leak prevention. In some engines, lubricating oil film helps to seal clearances between pistons and rings, reducing blow-by of combustion gases and preventing oil leaks. Those are 4 functions of lubricating oil. We just have to state them. We don't have to explain them so deeply, but that's good explanation as well. Part B is explain each of the following terms: hydrostatic lubrication and boundary lubrication. So hydrostatic lubrication utilizes an external pressure source, such as a pump, to force oil between bearing surfaces. Hydrostatic, so it's like hydrostatic pressure, is what they're saying. So you've got a header tank, and your header tank will be full of oil, and that will push the oil into the engine. The pressurized oil film separates the moving parts completely, preventing metal-to-metal contact. The advantage of this is it provides a very effective lubrication regime, offering excellent wear and protection and minimal friction. It is well suited for high-load applications. Now, boundary lubrication. The description of boundary lubrication is: boundary lubrication occurs when the lubricating film oil is too thin or the pressure between the bearing surfaces is too high to completely separate them. In this regime, special lubricants additives play a crucial role. These additives form a microscopic protective layer on the surface metals, reducing friction and wear even under conditions of partial metal-to-metal contact. Boundary lubrication. So boundary lubrication is where it just touches, where the metal's touching. The disadvantages are boundary lubrication offers less wear protection compared to hydrostatic lubrication, and is more susceptible to friction increase under high loads or extreme temperatures. So it doesn't give as good as protection, boundary lubrication. That was explain each of the following terms. Part C is state one advantage and one disadvantage of using grease as a lubricant in a plain bearing. Okay, grease as a lubricant in a plain bearings. The advantage is they give long service intervals. Grease has a thicker consistency than oil and can stay in place for longer periods, requiring less frequent relubrication compared to oil in plain bearings. This can be beneficial for applications where access to lubrication points is difficult. Disadvantages is heat dissipation. Grease generally has a lower heat transfer capacity compared to oil. This can be a disadvantage in high temperature applications where efficient heat dissipation is crucial for preventing overheating of bearing components. February 2021, Part 6 is explain the principle of operation for each of the following types of lubricating oil filter. So we've got different lubricating oil filters. We've got a magnetic one, centrifugal, coalescer, and plate edge, e.g. auto clean, spelled with a K. Alright, so that's 2 marks, 2 marks, 3 marks, and 3 marks. Magnetic, 2 marks, centrifugal, 2 marks, coalescer, 3, plate edge is 3. Lubricating oil filter principles. Here's a breakdown of the operating principles of each type of lubricating oil filter. The magnetic oil filter. The principle is a magnetic oil filter utilizes strong magnets to attract and trap ferrous, iron-containing wear and debris in the lubricating oil. Right, so it sucks out all the metal components that have been chipped off during the operation of the engine because they're metal, they're iron, and they can be pulled out. Okay, operation. As the oil flows through the filter, the magnet attracts ferrous particles suspended within the oil. These particles are held onto the magnet, preventing them from circulating within the engine and causing further wear. The benefits of it is a simple and relatively inexpensive design, effective at removing large ferrous particles. The limitations is it doesn't remove non-ferrous wear debris or other contaminants like soot or dirt. Requires periodic cleaning or replacement of the magnet to maintain effectiveness. Part B is the centrifugal oil filter for lubrication. Centrifugal oil filter. The principle is centrifugal oil filters utilize the principles of centrifugal force to separate contaminants from the lubricating oil. So it spins it around and the contaminants will be heavier or lighter than the oil. Operation. The oil enters the filter and is spun at high speeds with a rotating element. Centrifugal forces push denser contaminants like wear, debris, and dirt outwards away from the oil. The clean oil then flows through an outlet, while the separated contaminants accumulate in the collection chamber. The benefits are it can be effective at removing both ferrous and non-ferrous debris, so if it's not magnetic, it can still pick it up. So the benefits are it can be effective at removing both ferrous and non-ferrous debris along with some heavier contaminants. So it can pick up non-magnetic material as well as magnetic material. The limitations are a more complex design compared to magnetic filters. They do require a source of power to spin the element. May not be as effective at removing very fine particles. Part C is a coalescer oil filter. The principle is a coalescer oil filter targets water contamination within the lubricating oil. They utilize a specialized media that allows oil to pass through but causes water droplets to coalesce into larger droplets. The operation is as the oil containing the water droplets flows through the coalescer media, the water droplets come into contact with the fibers. The surface tension of the water causes the droplets to combine, forming larger water droplets. These larger water droplets can then be separated from the oil by gravity or differential pressure within the filter. The benefits are effective at removing water contamination from the lubricating oil, which can be harmful to engine components. The limitations are may not be as effective at removing solid contaminants like wear debris, may require replacement of the coalescer media at specific intervals. You got to change the filter basically in the coalescer filter. Okay, last one is D, is the plate edge filter, AEG Auto Clean, spelled with a K, K-L-E-A-N. Principle: plate edge filters, also known as automatic self-cleaning or edge filtration systems, utilize a series of stacked metal discs or plates with specially designed edges. The operation, how it works, is the oil flows through the narrow gap between the stacked plates. As the oil flows, contaminants get trapped on the edges of the plate due to their size and differential pressure. And a cleaning mechanism, often a wiper blade or differential pressure system, periodically removes the accumulated contaminants from the edges, allowing them to fall into the collection chamber or to be flushed out of the system. The benefits are continuous filtration and automatic cleaning provide excellent service intervals compared to some of other filter types. They can be effective at removing a wider range of contaminants. The limitations are a more complex design compared to basic filters, may require maintenance or replacement of cleaning mechanisms.